Hi everyone, this is Darshan Senthil and welcome to this third video on quadratics. I know it's getting a bit long now, but yeah, I'm just trying to cover all the essentials of quadratics that teachers will ask you about so that you can be well prepared when they throw quizzes and tests at you with this kind of stuff in it, okay? And I'm trying to link the concepts as they would best be represented, so I don't make too many videos and I don't make them too long either. So I'm just doing about two concepts at a time, one based on solving and one based on one sort of form of quadratics. Okay, so in this video we're going to be talking about vertex form, and we're going to be talking about completing the square. Okay, so these concepts go together well, and that's why I'm teaching them together. So let's get started. So first let's look at vertex form. So if you remember from last video we talked about standard form. So this time we're going to be talking about vertex form. And vertex form is basically written as follows. Y equals a x minus h plus x minus h squared plus k. And you may look at this and you'll be like, whoa, what the hell are you talking about? And don't worry, it's not that bad. So this is basically gonna be your x, okay? These two over here now, okay, your h and your k, they form your transformations. Let me tell you what I mean by that. So h describes how far you move on the x-axis, excuse me, and k describes how you move on the y-axis. If you're still confused, so let me just explain this. So h tells you, supposing I've got like a graph like this, h will tell me how far this way or this way the graph has translated. So you see, we're describing a translation here, transformation. The h describes how far left or right the graph could have moved, okay? And the k describes how far up or down the graph could have moved, okay? So yeah, so these two things are our transformation factors. So they tell us how much the graph has moved, okay? So in previous videos we discussed a quadratic around the origin. Now vertex form lets us describe graphs that are not at the origin, like over here or over, like, wait, no, like over here. Like, you can describe this using vertex form, okay? So this is something that you should probably take note of, because this is something teachers love to quiz you on. So as they love to quiz me on this. So yeah, you should be familiar with this. Like, how far, what do x and k do? Sorry, h and k do. And also, from this, if you know that these two describe your transformations, then in the end, the point h comma k has to be your new vertex. So assuming your parabola, let's just do a little example here. Let me just clear this stuff first. Okay, so you will have, supposing you've got a parabola, like a parabola here, and it moves two to the right and 3 up. That means it'll be over here, right? Which means that your new vertex will be at the point 2, 3. And that is how h and k represents your new vertex. Okay? So yeah, that's about h and k. And now a describes kind of like it's kind of like a slope in ways. It's sort of like, in a way, it describes the slope. So it describes which way the thing is pointed. So for example, if your a is negative, you will end up with a parabola like this. And if it's positive, you'll end up with something like this. Also, it describes how thin or thick it is. Okay, so for example, if you have, you could have a, let's just get rid of that for a second. So for example, you could have a parabola that looked like this. It's pretty thin. Or you could have a parabola that looked like a soup bowl, like this. Whatever that is, if it's thick or thin, then this a value is responsible for that. Okay, so exactly how that works is, I'm not going to put that in here. I want you to experiment with that and see how it works. So try out different things, like plug in a fraction for a, and then try plugging a negative number, plug in a positive number. Try all that stuff out yourself, and then I want you to see how that works. Okay, I'm not going to put it on paper here for you because I don't want you to memorize. I want you to try out and see how it works, because that is how I feel is the best way to know it. Because then even if you like forget it in the middle of a test, you can pull out your graphing calculator and try it out, and you'll actually understand that better. And you don't know how many times I've done that myself. So this is really, I'm encouraging you to try and find that out yourself. You can, there's this lovely calculator app called desmos.org. If you looked it up, you can see that you can try use that as well and just sort of figure out how a affects your parabola. Okay. Also, you can try to see what h and k do as well. Okay, so that's how it works. And also, since it's got the hk new vertex, that's why it's called vertex form as well. Now, some people like to call this standard form, but for our purposes, we're just going to call it vertex form because we've already got a standard form as well. So some teachers may refer to this as standard form, some teachers refer to that as standard form, but just don't worry. Just know what this teaches you as well. Just the name is not important, but the concept is. Okay, so just make sure you know make sure you're able to distinguish between the two forms. Okay, so that's what this stuff does. So now I'm going to tell you a little bit about completing the square. So completing the square enables you to turn standard form into vertex form. Okay, and by doing that, let me just show you what it does. So for example, if you had an equation like this, if you had something like this and you expanded this, you would get, let's try expanding this right now. And what we're doing here is called foiling. So I think I'll just touch upon that as well, but I'm going to make a more in-depth video on how to foil later sometime soon. So here I'm just going to like do it pretty quickly. So here we get x squared plus 2x plus 2x plus 4. Simplify. And this is a standard form equation. Now this same equation, we could condense it back into this. So we would be able to write it as x plus 2 squared. Now that's really convenient, but we can't do that for every equation. So if we had equations like this, we would be able to switch between standard form and vertex form very easily. Okay, because we know how to condense them. They're already ready for that. But some equations, for example, let's pick a pretty ugly one. X squared plus 6x plus 1. This is not a perfect square equation. This is a perfect square equation. Square. This is not a perfect square. And to understand the perfect square concept, just think about like numbers like 64. This is a perfect square. 64 is 8 squared. And let's see, 4 is 2 squared. That's exactly what we're doing here. So just as 4 is 2 squared, x squared plus 4x plus 4 is x plus 2 squared. That is exactly what is happening here. But some equations are not like that. As you know, for example, 66 does not have a perfect square. So the whole purpose of completing the square is to take equations like this and put them into something like this to make them a perfect square. So we can write it in our standard, in our vertex form equation like this. So we can write it like this. We want to make it a perfect square. I hope I haven't confused you too much. So yeah, I'm just going to show you a little example problem as to how we would do that. Okay. So here's my little example. So, oh yeah, and before we get started, it's important that you know these two equations up here. So a plus b squared is equal to a squared plus 2ab plus b squared. A minus b squared is a squared minus 2ab plus b squared. I don't know, usually it's more convenient if I use x and y, but I just like a and b better for this particular equation. So, but you just get the general idea. So a squared plus 2ab plus b squared, blah blah blah. Okay, so that is that. So these two equations are pretty crucial for knowing how to complete the square. So I would recommend you memorize them. But if you ever forget, you can always just try. You could just try foiling this out. And if you just like we just did this. If you just perform this operation, you would eventually get this answer, but it just takes a little more time, and just knowing how to do it directly is just much more simpler. Okay. So now let's just get started on how to complete the square here. So when you complete the square, again, you should make sure that it's equal to 0. It's always helpful. So what we need to do is, we do not like this term up here. We don't like it when we have something we don't like having an a value here. So, because if you notice here, in all these equations, we have a by itself. So we don't want another coefficient for this. So we want to pull out this coefficient. So what we do is, we will sorry, I'm a bit of a perfectionist. So we're going to pull the coefficient out of, now listen carefully, it's going to get a bit tricky, out of only the first two terms. Okay, x squared minus 2x, and the plus 6 stays as it is. Okay, so our first step would be pull first coef out of first two terms. Only the first two, okay? Just keep that in mind. And after that, we need a value over here, right? For b squared. So to do that, what we need to do is we're going to use this 2ab thing. So we know our a, that's x, and we know the 2, which is 2. So what we need to do is, we take whatever is here, we just pull it out, just temporarily, we're just going to look at it over here. We're going to divide this thing over here, whatever coefficient we have here. We just ignore the x, divide this coefficient by 2, and square it. Okay? So our second step would be to take second coef. Remember, we take out only the coefficient, we don't touch the x, okay? We take out the second coef, divide by 2, and square. So we square the whole thing, as you see here. And then this will give us our b squared. You get it? So once we've taken this, so it's basically like we're solving for b here. So we take the 2ab, we already know our a, so we can just sort of forget about it. So we take this divided by 2, we get b. And then we square this, we get b squared. That's it. That's all we're going to do. That's all we're doing. So if you understand this concept here, you can forget what I say, and if you go write this on a test or quiz, you should be able to do it. So my goal is to help you get the concept behind this, like why we do what we do. Like you can memorize a bunch of operations and still fail, but if you understand the concepts behind it, then you'll do a lot better. Okay? So you've got the 2 by 2, and you square this, and the answer to this is basically just 1 squared, which is 1. So we're just going to put 1 over here. Now, we can't just simply add 1 to an equation. We need to balance it out. So what we're going to do is, we need to add something to this side of the equation as well, to this 0 here. So we're going to need to add... So what did we add here really? Now here again it gets a bit tricky. What did we add here? It looks like we added 1. Don't forget this guy. We have a 2 out here. So really what we added is 2. We added 2, not 1. So we're going to have to add 2 to this side as well. Okay? So let's see. So once we've got this, add that to both sides. Okay? So this is how we would do that. We just add 2. We added 1 here, but since we have a 2 out here, we multiplied it. So we need to add 2 out here, not 1. Okay? So then next step, we're just going to simplify. So now we have this term out here. And so once we've got this, we've got what we wanted. We've got our a plus b squared or a minus b squared. Since we've got a negative here, it's going to be a minus b squared. So either way, we've got what we wanted. So, excuse me. So in this case, we just have to condense now. So we have our 2. And then this guy here is going to condense down to x plus, as x minus 1. Because the square root of 1 is just 1. And if you remember from this, if we just remove... An easy way to figure out what goes here would be to go back here and just remove the square. Okay? So in this case, it doesn't matter because 1 squared and 1 is the same thing. So we get x minus 1 squared. So we put x minus 1 squared here. Oopsies. X minus 1 squared plus 6 is equal to 2. Now finally, we just want to put this all in a nice little vertex form like thing. So we're going to subtract 2 from both sides. So set to 0. That's our final step. So we just basically need to subtract 2 from both sides. I'll do that in a different color. It's pretty cool how red matches. Red looks always looks good for subtraction. So in the end, we get 2 x minus 1 squared plus 4 equals 0. That, my friends, is our final answer. Now with this, we could do a lot of things. Now we could ask you for a lot of things from here. You could solve, get the zeros from here, because it's really easy actually to solve for the zeros over here. You could graph this. You could find the components. Vertex, etc. So there are a lot of things you could do with this. So let's just list a few of them to start. I'm not going to graph it because it's we don't have enough space. So let's just start by listing the components. So our vertex, what's it going to be? X minus, so we've got x minus 1 and plus 4. So you need to be a little bit careful here, because if you remember, our equation had x minus h squared plus k. Okay? Minus h. So if we've got a minus 1 here, it means that h is actually positive. So we're gonna have our vertex as +1 and plus k, we got +4. So 4 will be our vertex. Okay, so that's that. And then we can also find the zeros here. So yeah, let's just find the zeros. So 2x minus 1 squared plus 4 is gonna be equal to 0. We can subtract 4 from both sides. So we get 2x minus 1 squared is equal to -4. Divide by 2. X minus 1 squared is equal to -4 halves, which is -2. And I'm just going to take this a little bit in here. So then but then you realize here that once you've taken the square root, you actually can't do this. You're going to get a non-real answer because you cannot have the square root of a negative number. So if you were asked this, you would just simply say no real zeros. Okay, I don't think you can read that, so I'm just going to write it again. So since you've got a negative number under your square root, you would have no real zeros. That would be your answer if somebody asked you to find the zeros of this. Of course, you could later go back and talk about like unreal, like I and stuff like that, like complex numbers. You could get a complex number for the answer, but then again, it's a little bit like I haven't taught you that yet, so for now I don't think you'll need to know that. But if somebody else asks you, you should be able to give an answer with I and stuff. But that is only if they've taught you about I, which I haven't. So for this case, you'll not need to know anything else. So just say no real zeros. Okay. So this is a pretty complicating video, I know, but I hope it helped. Just hope I managed to clarify some stuff for you, and hopefully I've been able to help you learn this and understand the concepts behind it, and hopefully you'll be well prepared for later stuff. Okay, so thanks for watching.